So let's consider the best response of a player in a game. So if a player should select that strategy that yields the greatest expected payoff against his or her belief. In that case, that strategy is called a best response, or you can call it best reply. So formally, you can write the definition of best response. So let's write it down. Suppose player I has a belief theta sub minus I belonging to delta S sub I minus I about the strategies played by the other players. So player I's strategy SI belonging to SI is a best response if UI of SI given theta sub minus I is greater than equal to UI of SI prime given theta minus I sub I for every SI prime belonging to SI. So this formal definition of best response is saying that every player has some belief about the other player's strategy. So we denote those beliefs with theta sub minus I. So this tells you this is player I's belief about the other player's strategy. So player I's strategy SI, this is pure strategy SI, belonging to the set of strategies for player I, is a best response if the payoff for player I from playing SI, given his belief about other players' strategy, is at least as good as the payoff that player I gets by playing a strategy SI prime and the strategy of player I, given his belief about other players' strategy for every SI prime belonging to SI. So this is the formal definition of best response. Next, let's try to find the best response set for players in a game. So let's consider a static game here. So let's say the game is a 3x3 game. So I'm going to write it here. Okay, so it's a 3x3 game. So players 1 and 2. Player 1 has 3 strategies: play up, middle, or down, and player 2 has 3 strategies as well: play left, center, and right. And the payoffs are, say, 2 to player 1, 6 to player 2, and so on. So 0, 4, 4, and 4, 3 and 3, 0 and 0, 1 and 5, 1 and 1, 3 and 5, this is 1, and 2 and 3. So it is possible that there be more than one best response for a player given his belief. And it's not difficult to show that in a finite game. Every belief has at least one best response. So for any belief, theta sub minus I of player I, we can denote the set of best responses by writing BRI given theta minus I. So best response of player I given his belief about other players' strategy. This is how we denote the set of best responses. So let's consider this game that I have just drawn here. So suppose player 1, forms a belief about player 2's strategy, and suppose he thinks that player 2 will play L, this strategy, with a probability of 1/3. All right, and he will play strategy C with probability 1/2, and he'll play strategy R, so R is here, with a probability of 1/6. Okay, so this is player 1's belief about player 2's strategy, right? So since we have 2 players, I equals to 1, 2, so then this is theta 2 basically. Player 1's belief about player 2's strategy, right? So this is the belief of player 1 about player 2's strategy. So given this belief, if player 1, let's say, selects strategy up, right, then his expected payoff is going to be, so expected payoff of player 1 from strategy up, and his belief, right, we have this belief, we call it theta 2. This is your theta 2. This is player 1's belief about player 2's strategy. So minus I, right, subscript minus I is basically 2 here. Player 1's belief about player 2's strategy. All right, so given that, his expected payoff is going to be, so if player 2 plays L with probability 1/3, then player 1 is going to get 2. So 2 times 1/3 plus 0 times 1/2, because if player 2 plays C with probability 1/2, player 1 will get 0 by playing up, and then he'll get 4 if player 2 chooses R with a probability 1/6. Okay, so in this case, expected payoff is going to be 8/6. Similarly, we can find player 1's expected payoff from middle and down, right? So let's calculate those. So from middle, given his belief about player 2's strategy, so this is, so player 2 is going to get 3 times 1/3 plus 0 times 1/2 plus 1 times 1/6. Okay, so that is equal to 7/6. And if he plays down, given his belief about player 2's strategy, then his expected payoff is going to be 1 times 1/3, right? So 1 times 1/3 plus 3 times 1/2 plus 2 times 1/6. And in that case, his expected payoff is going to be equal to 13/6. All right. So therefore, his best response here is strategy D, the strategy that yields the greatest expected payoff given his belief. Strategy D is his only best response. So therefore, we can write that best response of player 1, given his belief 1/3, 1/2, and 1/6 is equal to D. Keep in mind that because best response is a set of strategies, we enclose its elements in brackets, even if it has only one element here. Right. All right, so that's how we find the best response of a player. So we can continue, and we can, in this example, we can find the best response of player 2, given his belief about player 1's strategy. So let me, so this is the game we're going to use, but I'm going to move on to the next page here now. So let's calculate that. So now let's suppose player 2's belief about player 1's strategy is, so let's say, so we are going to look at the player 2's belief now. So let's say player 2 has this belief that player 1 is going to play up with a probability of 1/2, middle with a probability of 1/4, and down with a probability of 1/4. Okay. So this is player 2's belief about player 1's strategy, right? All right. So next we can calculate, the expected payoff for player 2 when he plays left, center, or right. So player 2's expected payoff from playing left, given his belief about player 1's strategy, which is given here, right, is going to be equal to 1/2 times 6, because player 1, is going to play up with probability 1/2, and in that case, player 2 by playing L will get 6, right? And if player player 1 plays middle with probability 1/4, then player 2 by playing L will get 3. So in that case, we have 1/4 times 3. And then if player 1 plays down with probability 1/4, then player 2 will end up with 1 if he plays L. So this is equal to 4. And similarly, he can expect to get, so by playing center, given his belief about player 1's strategy, his expected payoff is going to be, so 1/2 times 4 plus 1/4 times 0 plus 1/4 times 5, which is equal to 13/4. And if he plays right, then his expected payoff is going to be equal to 1/2 times 4 plus 1/4 times 5 plus 1/4 times 3, which equals to 4. So the best response of player 2, given his belief about player 1's strategy, which are 1/2, 1/4, and 1/4, is the set consisting of L and R, because L results in an expected payoff of 4 and R results in expected payoff of 4. There's a tie. So both strategies, left and right, for player 2 are best responses given his belief about player 1's strategy here in this game.